Okay, guys, this is going to be the first day of 4.7, and it's inverse trig functions. So the first thing I'm going to do is I'm going to bring up the calculator, and I'm going to show you a sine function first, just so we can kind of get the background for what we're doing here. Okay, so sine of x, and if I zoom 7 it, here's our sine function. So if you remember inverse trig functions, they're reflections over the line, y equals x. So if I would, I need to kind of trick the calculator to draw the inverse sine function. So to be able to do that, I am going to go to my draw menu, which is second program, and I am going to draw the inverse of where I put that function, so y2. So I'm on my home screen. I'm going to my draw menu, which is second program, and I'm going to draw inverse 8. And my function is in y2, so I'm going to go get y2, vars, y vars, function y2, and make sure you're watching the screen because it's going to draw the inverse trig function. So awesome. So our red one is our regular sine function, and our blue one is our inverse sine function. Okay, so now the issue here is that the blue graph is not a function. It fails the vertical line test. That would happen with cosine. That would also happen with secant and cosecant. And it would also happen with tangent and cotangent. If you remember to how to determine if a function and its inverse is also a function, that's the idea of the definition of one-to-one. So one-to-one means a function and its inverse are functions. So if you think about the 6 trig functions, the 6 trig functions do not pass the horizontal line test. So all of their functions will not be, all of their inverses will not be a function. Okay? So what we're going to do is we're going to limit the domain of each of the inverse functions so that it will be a function. Okay, so here's 2 notations on how you can see inverse functions, right? So you can see it as, you can see it as inverse sine with that -1, or you can see arc sine. So the function sine of x is our regular function. The function inverse sine of x is our inverse functions. So these are 2 totally different functions. If I bring that graph back up, and I can go to y, I'm going to go to y4 just so that it's the magenta and you can see it. And I do second sine of x. I might have to change my window, but let's see. There you go. You saw it right there, right? So it's this little piece. Whoops, let me put that on the screen, right? It's this little magenta piece right here for our inverse sine function. So we're going to limit the quadrants. Okay. So in order to limit the quadrants, we're going to make them make sense first. Okay, I need a new page. Okay, so if we were together, I really show you the background why these work this way, but I'm just going to explain it based upon our A, our S, our T, and our C. So the reason that our functions aren't one-to-one, our regular functions, is because I've got 2 places where sine can be positive and 2 places where sine can be negative. And that's going to happen for all of our 6 trig functions. So what we're going to do is quadrant 1 is nice because everybody is positive there. So the inverse sine, the inverse cosecant, the inverse cosine, the inverse secant, the inverse tangent, and the inverse cotangent are all going to be valid for quadrant 1. So you're going to use this quadrant 1 only, when we're looking for positive values of our 6 inverse trig functions. So then that means we only need a negative part now. So our negative part, one idea of the quadrants that you want to use is you want them to be consecutive. You want to have a nice domain or range of values. So let's say for sine and cosecant. Well, sine and cosecant are positive in quadrant 2, and I need their negative version. So in quadrant 4, it's going to be the negative version, inverse sine and inverse cosecant. So this is where the two inverse functions are positive. This is where the two inverse functions are negative. Okay, so let's do cosine and secant next. Cosine is secant in positive in quadrant 4. So I want a negative version. So the negative version is going to be in quadrant 2 for the negative versions. Okay, now tangent and cotangent are a little different because they're positive in quadrant 3, but quadrant 3 is not a consecutive quadrant. So we are either going to choose quadrant 2 or quadrant 4 for your answer. So we're going to go back to graphing. Tangent, when we graphed it, was from negative pi over 2 to pi over 2, so we're going to stick with that same thing. Negative pi over 2 to pi over 2 is going to be for where our inverse tangent function is negative. And then cotangent was graphed from 0 to pi, so we're going to stick with that for inverse cotangent. So inverse cotangent is going to be negative in quadrant 2. So I'm going to bring up another smart. Let me close this stuff and get it out of the way. So we actually have some limitations for our inverse trig functions, and your answer has to be in those limitations as well. So I'm just going to pull 2 slides over to the other notebook. Okay, and this is the slide that I want. Okay, so the domain and range is an important slide to kind of talk about. Okay, so if I talk about the trig functions that were in quadrant 1 and 4, that was our sine, our cosecant, and our tangent. So the domains for those, right, are kind of the normal domain, range for sine, range for cosecant, range for tangent, right? Because in an inverse function, we flip-flop the domain and range. Here's the important part. Your answers need to fall between negative pi over 2 and pi over 2. So here's kind of some rules that you can follow. If your answer is positive and it's supposed to be in quadrant 1, you kind of just leave your angle alone. It's either pi over 6, pi over 4, or pi over 3, or something like that. If your answer is in quadrant 4, we're going to take the negative of that angle. So for example, if we had the inverse sine of negative a half, well, my reference angle for that would be pi over 6. That's my reference angle. But I have it negative, so that means it needs to fall in quadrant 4. So I'm not going to say 11 pi over 6, because 11 pi over 6 doesn't fall inside that range. All I'm going to do is take my reference angle and stick a negative in front. 11 pi over 6 is in the exact same location as negative pi over 6, but negative pi over 6 falls inside that range. So that would be our acceptable answer, negative pi over 6. Okay, so our other ones, our cosine, our secant, and our cotangent, were all in quadrant 1 and 2. So those are our normal ranges of the original, so they become the domain of the inverse. And this one's pretty easy. It's either going to be in quadrant 1 or quadrant 2. So we already have our quadrant 1 rule. So our quadrant 2 rule, if I have a reference angle of pi over 6, then all I need to do is go pi minus that to get 5 pi over 6. So in quadrant 1, you leave the angle alone. In quadrant 4, you stick a negative in front. And then in quadrant 2, you're going to go pi minus that reference angle. Okay, so the first thing that we're going to do is we're going to actually use the calculator. So using the calculator, there's kind of a good thing. We can trust our calculator for 11 out of 12 instances. Sine, we can trust it if it's positive or it's negative. For cosine, for secant, for cosecant, for cotangent, we can trust it for all positives and negatives. I lied. It's tangent, not cotangent. We can trust it for all of our positive and negative amounts. The one that we have to be careful for is cotangent. And it's only cotangent when it's negative. And here's the reason why. When I go do it in the calculator, I'm going to actually be hitting a tangent button. And tangent thinks it's supposed to be quadrant 2. But cotangent says it's supposed to be, I apologize. I'm thinking the wrong function. Give me 1 second and I need to fix this. Hold on. All right, so let's explain this again because I was kind of saying it backwards. Sorry. Okay, so we have cotangent and we have tangent. Okay, so tangent is in between negative pi over 2 and pi over 2 for the inverse trig function, and cotangent is between 0 and pi. Okay, so when we hit the tangent button, it's going to know if it's supposed to be in quadrant 4 or in quadrant 1, 0 to infinity. Okay, when you hit the cotangent button, there's no cotangent button, so we're actually hitting the tangent button. The tangent button is going to think that it's supposed to be in quadrant 4 when it's actually supposed to be in quadrant 2, pi over 2 to pi. So for cotangent being negative, and I've got a problem on the next slide that we're going to do, you have to be careful when you're doing that one in your calculator. Okay, so let's open up our calculator. I hope that was okay. And again, we'll do a problem, so I'm sure it will be fine. Not worried about it. Okay, so let's wait till the calculator opens up. Okay, these are the 6 problems that we're going to do. So if you remember when I would do these before, I would kind of take them in categories. And I would do the easy ones, then the hard ones. Right, so we're going to go to our home screen. We're going to make sure we're in radian mode, which we are. Okay, so if I look at these, right, I would say that number 4, number 2, and number 5 are probably our easiest ones because those are all with the own button. Okay, so we're going to go to our calculator and I'm going to do number 5 first. So I'm going to go inverse cosine of negative 0.888. Okay, so it's going to give it to me in radians. So it's 2.66. So we trust ourselves and it's 2.66. Okay, so now let's go to number 4. Let's go to number 2 next. So inverse tangent of 2.5478. And I'm getting 1.2. Okay, so that's okay for 1.2. Now let's go to the sine. Inverse sine of 1.258. Think a little bit what you think the answer is going to be before you actually do it. Hopefully it didn't just surprise you that it's an error. It's an error because sine has to be between 1 and negative 1, and it's not. So no such angle exists. Okay, so now let's go do number 1 and number 2. So now for number 1, right, you got to kind of think about that a little bit. That's saying there's some angle whose secant is 5.367. So I don't have a secant button, so I've got to convert it to a cosine. Inverse cosine of 1 over 5.367. So that's what I've got to do. I've got to go inverse cosine of 1 divided by 5.367. We're still in the trusting calculator mode, 1.38. All right, so now cosecant. I'm going to do the same thing. I'm going to go second sign. 1 divided by negative 2.694. Again, it's still not an issue. I'm getting negative 0.38. All right, before we go to the last one, let's just kind of talk about a little bit. Okay, so let's look at our positive ones. Our positive ones are, trying to get the highlighter here, it's not going. Okay, so our positive ones, try to make it bigger maybe. Here, I'll use this. Okay, so our positive ones are number 1 and number 2. So if we think about those, when it's positive, it should be in quadrant 1. So that's in between 0 and half a pi, 1.57. So that's good. Okay, so now our negative one. Number 4 doesn't make sense, right? So I can ignore that one. All right, so then number 3, negative for cosecant should be in quadrant 4. There we go, that's in quadrant 4, negative angle. Negative cosine should be in quadrant 2. That's more than 1.57, but less than pi, so we're good. All right, now let's look at the hardest type, cotangent when it's negative. So I'm going to do inverse tangent of negative 8.564. So negative 8.564. All right, let's look at this guy. Ooh, sorry, my fault. I had to do 1 divided by, right? So second tan 1 divided by negative 8.564. 8.564. Okay, so the angle is negative 0.117. Okay, negative 0.117. So if it's negative 0.117, that is in quadrant 4. But our tangent is cotangent is supposed to be in quadrant 2. So this is going to be our reference angle, and all I need to do is go pi minus 0.117. So I'm going to go pi minus 0.117, and I'm getting the answer of 3.02. So that would be my final answer for this problem, 3.02. Okay, so I've got my 6 answers, little different with inverse trig functions going backwards. Replay this last part if you need to. But what you're going to do and what you're going to try is you are going to try 4 to 7, 13 to 20, all of them, and make sure you are checking your answers. Thanks, guys.